and I give to the first speaker, Arno Simons.
Thank you very much. Thank you all for coming. Let's get right into it. So what's on the menu today for my talk? I will, as a co-organizer, and also due to the fact that we are such a heterogeneous audience here, and I'm not sure if every one of you can follow on a very high technical level or not. So I think that one of my tasks will be to give you a short primer on large language models and their adaptation to science domains. Then to summarize some current applications in HPSS. And share a few critical reflections to be discussed throughout this workshop, hopefully. So this, make it bigger. So this is the famous transformer architecture. You may have heard of the transformer. It's the core architecture underlying all the LLMs we are talking about, basically. This model was originally designed in 2017 to translate between languages. For example, let's say from German to English. So it consists of two connected streams, 1, 2, and they are connected somewhere in the middle. And the left side is usually called the encoder, and the right side is usually called the decoder. The words come from the fact that the words from the German sentence will be fed in here, and then will be encoded into numbers, crunched around here. Then they will be sent over to the other stream where they will pop out words in English on top. And then each word that is popped out will get fed back into the ground again. And this will loop until the English sentence is produced. And within these number crunching things, there are different layers in which these contextualized word embeddings that Nina has so beautifully described to us are ever much more contextualized layer by layer. And the core difference between the encoder and the decoder side here is that in the encoder, so on the left side, the German sentence, each word in the German sentence, so the whole sentence is read at once, and each word can talk to each other word. So then the model builds a full representation of the complete meaning of the sentence. Whereas on the other side, in the decoder side stream, you can the English words can only look at their predecessors. They cannot look into the future. Because they need to predict the next word, but so they can't look back. They can look back, but not into the future. And so immediately after this model or this paper was produced, people started re-engineering each of these streams individually to produce so-called pre-trained language models. So now we're entering a new kind of territory where we're not talking about translation per se, but models that can speak or understand the language very, very well and can then be used later on with minor or more additional training to get some NLP tasks done. So on the encoder side, which was technically later than the decoder side, but this is for educational reasons better this way. So the encoder side was formed into a model called BERT, and the BERT family of models is very present still. And again, this one works by the fact that each word in the input stream can listen to each other and thereby produce a full context understanding of the whole input at once. And this model is called BERT, which stands for bidirectional encoder-based representations from transformers. And bidirectional means that these words can look in both directions. And encoder-based because it comes from the original encoder, but these words don't matter that much anymore. And so on the other side, we have the GPT models. GPT stands for generative pre-trained transformers. And it's, of course, the stuff that powers now ChatGPT, GPT, ChatGPT, etc. And these models, since they have this different type of structure where they can only look at the predecessors, but on the other hand, they can generate new words, which the BERT models cannot really do. So we can produce new text with these models. So they really do different things. And of course, there are these are not the only two differences. There are models that combine encoder decoders. There are also ways of using decoders in a super fancy way to make them work more like encoders, more like BERT models. It's basically the model that Perlugio was showing us, also the XLXeme, which builds on XLNet, which is one of these, but we don't need to go into detail. I think it's core to understand these differences between the generative models on the one hand understand, that produce language, and the full context models, BERT-like models that understand sentences more coherently. Yes, great. So let's go on. So this is an overview of the evolution of large language models with a specific focus on science domains and tasks. We don't need to, it's just an idea for you to see that there is a variety. We have the encoders or the BERT type models here, much more populated as you can see. And then there's decoder models here, less populated. Basically also showing that, that for our types of, or this is for science, but we as history, philosophy, sociology of science would probably want to use such models or build our own models. But it shows that there's a lot going on in the encoder side also. And there are these important first models maybe you've heard of. Where is it here? BioBird must be here, or Spectre, or Cybird. These were some of the most popular first models. And yeah. But there are all types of models now for biomedicine, chemistry, material science, climate science, math, physics, social science, and so on. These models, the question is, how do you actually adapt them to specific science language? And the first one was already said, this is this so-called pre-training. So the first time the model sees language and it learns this language either by predicting the next token, as in the GPT models, or by predicting random masked words, as in the BERT model. Basically, pre-training requires way too much compute and data as that we could ever really do this, to be serious. We can do continued pre-training, so we use an already pre-trained model. That's, for example, what Micha and I did in our studies. We used a BERT model that was pre-trained and trained it on physics language. But we can also use these pre-trained models on the top, for example, and then put some extra layers on top and train them to be classifiers, for example, for sentiments or for named entities. We can also do some prompt-based stuff, but I will not go into this. I briefly mentioned contrastive learning, where, for example, a BERT model is used because this is the key thing. We have these word embeddings, but we don't have yet sentence embeddings or document embeddings. But we want to put documents or sentences in the same type of embedding space as the words that Nina showed us, or Pelugio. So what we need is to do this, and contrastive learning is the key method. Sentence BERT basically is what everyone uses now, or it's a famous one. And actually, what's her name? She's our second keynote tomorrow. I'm sorry, Irina, sorry, Gurevich. She will do. She may talk about sentence BERT a bit. But the problem, yeah, I will not go into this. Time is running. But just yeah, I will come back. You can see things like, maybe you've heard of RAG, which stands for a retrieval augmented generation. This is a pipeline that we will actually have several presentations here that will talk about this, and you will see it whenever you use ChatGPT nowadays. You're basically doing RAG all the time, because ChatGPT is, for example, searching the internet and presenting you results. What this means is this is a way of adapting your model to a domain, for example, to our science domains, without necessarily training the model. But here we actually don't have one model. We have at least two or more models acting in concert in a system like this. So here you see there might be the BERT type models responsible for scoring similarity between your user query. For example, my question is, what are LLMs? Then my BERT model encodes this into a sentence embedding, and then it looks in a database with a lot of my documents that I'm interested in, and gets the most similar ones, or the similar passages from my document. What? Okay, and then the pipeline will then integrate these retrieved sentences into the prompt of my actual generative model, which will then, based on this new context, produce my answer. So this is what happens nowadays. Also, reasoning models or agents that we talk about now, these are not single LLMs. These are systems of LLMs combined with lots of other tools. This is just important to know. So I want you to remember at least these important distinctions as a primer. So we have these different architectures. Yes, we have various fine-tuning strategies, word versus sentence embeddings. It's really key. It's a totally different thing in the end. And these levels of abstraction. So we are currently conducting a little survey on uses of LLMs as tools in HPSS research. And we have found, we have come up with 4 bins where we try to sort these things into. So I'm just very brief now with the slide because it's not the most important one. So there's dealing with data and sources. How do we actually talk to our data? How do we find it or parse it? Then there's knowledge structures that we might be interested in analyzing. For example, we extract entities like scientific instruments, celestial bodies, chemicals, whatever, mappings, of course, classical HPSS sujet. So science policy discourses, interdisciplinary fields, etc. Dynamics, what Micha and I were doing, basically the stuff that Nina and Perlugio showed us. We basically did the same stuff. Conceptual histories of words. But there are also knowledge practices like this citation context analysis, which is actually an older tradition in HPSS, which is nowadays only used for evaluatory purposes, but can be used for other HPSS tasks. We find actually a trend that there is an accelerating interest in LLMs. Most of our findings are in journals like Scientometrics and JASIST, so more the information type journals, but we do also find more papers now in journals that are traditionally not computational friendly journals, which is interesting and shows that probably due to the semantic power these models have, they will now be more interesting also to qualitative researchers and philosophers and so on. There are varying degrees of customization. We have people that just use ChatGPT off the shelf, and we have people that actually develop new architectures on the other side of the spectrum. And we have repeating concerns. Overwhelming computational resources is a big concern. Opaqueness of models, lack of training data, lack of benchmarks, and then this trade-off between these model types. As Nina told us, there's not one model that fits all purposes. It's always the adequate model for a given purpose. And so there's a trend towards accessibility. For example, BERT topic, now the new thing that everyone uses for topic modeling, is super easy to use because it's maintained very well by the developer. Yeah. And now finally some reflections that we should keep in mind when we talk here and have these papers. First of all, we should really acknowledge the HPSS specific challenges that we have. And so these challenges are, first of all, as Nina also hinted at, historical evolution of concepts in language. And this is really crucial because these models, as she said, they are usually trained on modern language. So we need to find ways to either train our own models or think of how to use these models, knowing that they might make have biases, etc. We have also a reconstructive perspective. Critical reflective perspective in HPSS, so meaning that we don't usually read scientific texts and give them face value, but we try to read between the lines. We try to understand how the authors at the time of writing, what were they situated, in which context, why did they write the way they do, or what subtle discursive tool strategies they use, like boundary work and all of these things. And these models are not generally trained to detect this stuff. So we need to find ways of how we can actually have our models do this type of reading that we usually do in HPSS. And then we have problems like sparse data, multiple languages, old scripts, and all of that stuff. I think, therefore, we should build some LLM literacy. We need to understand these tools, both in terms of the theory and the actual implications of these tools. We may even need to learn some coding, although coding may go away more and more when we do more natural language processing type of coding. But I think we really need to do that. Otherwise, we have this problem that we always have when we just use off-the-shelf tools. They produce some cool visualizations, cool colors, and nice graphs, and so on. And we don't really know what to do with these. And yeah, we should develop our own shared data sets and benchmarks. And the last thing is that we should stay true to our own HPSS methodology. So while we need to translate our HPSS problems into NLP tasks, we need to keep our focus. So we need to make sure that these tasks like classification and whatever generation and summarization and all of these NLP tasks, that these don't kind of hijack our purpose. If you know what I mean. But on the other hand, there are new opportunities, I think, for bridging qualitative and quantitative approaches. We have some qualitative people here also at the workshop, and I hope that there will be more translation. I'm also always between qualitative and quantitative. That's why I really love these models. And we should also reflect on our own history that we actually have in prehistory actually of these models. So we have things like covert analysis, for example, that Calon and these guys developed, like Ari Rip and so on in the 80s, which they are A&T people and they have this theoretical mindset and developed these tools. And now Gerd is approaching and I'm getting scared. So I should stop, I guess, right?
Thank you for the presentation. It's already good as the organizer of the discussion when one is viewed as a threat. I collect questions. Yes, first hand. Just go ahead.
Hello. Thanks. It's very lovely. In your list of worries, the hallucinations didn't come up. Is there something you're in the list of worries about using LLMs for research like this? Hallucinations didn't show up. Is that something you're worried about in these things, or do you think within sort of HPSS context, it's easier to mitigate than in the very general sense that people are worried about when they're building them for search engines or things like that?
More questions? Yes, there.
Do you have some potential in multilinguality support for LMs? So let's say if you're asking question in one language and you're receiving answer in another language.
Other questions? Yes.
Thank you. Very interesting. I was just wondering if LLMs is still the good word, since the models are more and more multimodal and getting out of the language and the image and so on. Thank you.
Yes.
You talked about the challenge of sticking to HPSS methodology. Do you have an example of one? And do you have one example of a challenging case and how you could find an answer to with that in LLM with the usage of LLMs?
Other questions? I see some smiles, which is a pre-level before a question, but a question requires arms up. Yes, was that? Okay, thank you.
While we're on the topic of definitions, could you say something about what a large language model is versus just a normal language model? Because anyway, I designed my presentation assuming what I'm talking about is not a large language model, but I think perhaps it is. So I better get working.
I don't see hands anymore. Then we close the list at the moment and you have time to answer.
Thank you. I'm not actually scared of you, but a bit. Okay, so go through the list. Hallucinations, yeah, I could have put them on the list. Obviously, people also do find this is a problem. With certain type of models, hallucinations are problems of generative models, and generative models become increasingly better depending on which ones you're using. And so I think generally the problem will not go away completely, but it will probably get much better. We see, just for anecdotally, when I use ChatGPT, I think hallucination is not usually a problem with what I do, and I use it heavily, and it was more in the beginning. So then Then the multilinguality that came up. I'm not entirely sure what you meant, but there are models like that, of course. There are ways to do it. And again, I think the more important note for us, that's what my point is, we need to understand our purpose. And when we use multilinguality, maybe we have certain purposes for that. And then we need to understand by knowing these type of models. So which models should I use for my case? Or should I train one? But can I train one? Do I have enough resources? And so on. Just like Nina said beautifully with these things, like we have data, we have a problem, and now the question is, what model can we use on this problem with the given data we have? Because it makes no point to use some or try to train a model that if we don't have the data. So it really depends. And it just speaks to the fact that we should build this literacy. Is LLMs still a good word? Actually, I've wondered myself because they're becoming increasingly multimodal. We have images, we have sound, we have all sorts of things. So probably not. And again, it's just showing how fast language changes. So it's the same question with large language model. What is large? I still consider what I did. I continued pre-training a BERT model. 100 million parameters. I was like, wow, 100 million numbers in my computer. But it's ridiculous now, of course, compared to GPT-4. So I don't know, actually. But it's an open question, of course. And I mean, the development is so fast that we also need not only literacy of the stuff we have, but keep some eye on what's going on. And these agents are coming up now. Everyone's speaking about agents, and we might build our own agents that do stuff for us. We will soon have maybe conferences where there are some agents with us in the Zoom chat. Seriously, and we might talk to them, and we might speak with them, and so on. So I think the development is fast. Good news, I think, is that we in STS and HPSS have language for that for a long time. So the whole ANT, actor network type of language is actually very well suited for this. And computer science people that I listen to in podcasts actually show up talking like ANT language. It's really interesting. So I think also from the theoretical part, we have a good place to start. There was a very important question. Is there any challenge that in HPSS that could be solved now better or at all with large language models? Was somewhere here you asked it. Super important. I think I'm not sure I can, maybe because I'm nervous, give you this one example, but just these contextualized word embeddings, for example, that's what Micha and I were doing, these type of following words in their context over time. I think there's so much we can do with this. We can, for example, distinguish meanings of, I did it just as a showcase with the word Planck, Max Planck Institutes, Planck Satellite, Planck length, Planck whatever, Planck. And the Planck mission, for example, it showed up, I modeled the word senses of Planck, and I could see that the Planck mission sense increased in the archive physics world, and dominated in the end was one of the dominant sense, actually, compared to the other senses. And these kind of things, I have no idea how we would have done this without LLMs. But there might be other things. There might be things we have debated this. Gerd is not a fan of this idea, but for example, these whole ideas of paradigm and what is it called? That we can't understand each other from the Newton paradigm to the Einstein paradigm and so on. But there might be ways to find these to open up these problems with large language models. I'm not sure, but core problems of STS and HPSS. Thank you.
Thank you. I think that's then the conclusion of the discussion. If I may, thank you again for your presentation.